Welcome back in another video. We were doing set matrix 0 and we have optimized this problem from n cube to the n square time complexity, and for the space complexity we used actually RNC arrays, and now we'll be optimizing this problem further by not using RNC. Instead we'll be replacing RNC uh, with these rows, with this row and this column. But this problem in the meaning of replacing this first at this is 0, then we'll change this element to 0 and this element to 0, and that would be working the same. Like for this one we'll check if this element is 0 or not, or this element is 0 or not. If either of these is 0, then we will mark this as 0, and same with this, same for this element also. But there is a trick, there is a downside also. You see here, this is the original matrix, and marking 0 process change this array to this. So for this 0 we'll mark this one as 0, so this one is marked 0, and for the above upward thing this is 0 only, and for this 0 this one and this one will be 0, so this one will be 0, and for this 0 it's already 0, so 0. But now you here see, if we will we'll be proceeding with the algorithm according to this fillings of the 0. This one will become 0, but this one will not become 0. This one will become 0 and this one will become 0. This one will also become 0. This row and this entire column will be 0. But if you see, the answer should have been like this row would be 0, but this column should not be 0. So what is the thing that is doing something wrong in the algorithm? So basically this 0, 0 element can be targeted by these elements or by these elements. So like this element can only be targeted by this column, but this element can be targeted by this row and this column. So the basic approach is like, we'll just mark 0 by not traversing from here, but traversing from this element, like 1, 1. So that's what the approach is. And after also we need to check if this column is having 0. So like after filling all the 0 according to this matrix, the solution for this matrix will come, but the solution for this row and this column will not come. So we need to check if there is certain 0 in this in any of the column of this row, then we will fill all the elements with 0. And again for this column also we need to check by iterating over this column. If there is 0, then we will mark all the ones with 0, but there is none, so we will for this example, of course. So yeah, let's begin with the code. So for int, first of all we will be traversing from 1, 1, so I equals to 1. Let's change this to dot length I plus plus for int j equals to 1, j less than m of 0 dot length j plus plus. So yeah, if m of I of j equals to 0, so we will mark m of I of 0 equals to 0 and m of 0 of j equals to 0. So we have this loops, we have filled zeros for this matrix, and of course before that we need to check. Let's create two boolean arrays and we'll initialize it with false only. C equals to false. We'll check if this row and this column will have in the original matrix are having 0 or not. So yeah, for int I equals to 0, I less than m dot length I plus plus, and if m of I of 0 equals to 0, then mark r, so this will be r, right? So r equals to true. Similarly for C, we'll check. You must be wondering why didn't we check here and mark R and C with true and with true only? Just because it's changing the elements of the, here we didn't change, we want to check the row and column according to the original matrix only, but here matrix is changing, so we cannot check if there is a 0, like for this 0 it marked 0 here and 0 here, and we will check with like let's say we will check if this is 1 comma 1, right? So we will check 0 comma 1 or 1 comma 0 is 0 or not. So this will say it is 0, but and will mark R and C equals to true, but in the original matrix it is not. So that's why we will first check if there is 0 in row and column, and if it is, then we will mark R and C equals to 2, so that after putting all the zeros in this matrix, we will fill this row or column with 0 according to the, of course according to the R equals to 2 or C equals to 2 or not. So yeah, now we will mark, let's just copy this. Yeah, so if this happens, what we will do, we will simply m of I of j equals to 0, and that's it. We have now solved the problem for this matrix. Now according to the R and C values, we will fill the row and column. So if R is true, then just fill entire row with 0, and yeah, yeah. So if C is true, then traverse along column and mark all the elements of the column as 0. So that's it, I guess. Let's check. It's accepted. Now we will check. So yeah, now you see we completely removed R and C arrays, and now the space complexity is 1, the time complexity is n square. So that's it for today. Thank you.